Alright, so I want to demonstrate how to solve a system of equations with three equations and three variables. And we're simply going to use a version of elimination here. The basic idea is we're going to do a couple of eliminations which will both produce a two variable equation. So you can think of it as reducing this 3 by 3 system to a 2 by 2 system, which we can then solve because we've previously done that with 2 by 2 systems. So we just need to do elimination twice. So when you're working with a 3 by 3 system, you have a little bit of freedom in that you get to choose which two equations to use and which variable to eliminate from those two equations. So as I look at this system, there are a number of things we can do here. I might just go right for these z's. Those kind of stick out to me. I know that if I add those two equations, those two z's are going to be eliminated. So let's do that. So the notation I would put in here to help me keep track of the process is this. I'll call the first equation row 1. It really is equation 1, but I'm going to refer to them as rows. And so if I just notice that if I take row 1 and add it straight to row 2, I'm going to get what I want. That is, I'm going to be eliminating the z term. So there's row 1, here's row 2. I'm just writing them down so that I can add them and see what we get. We get a 3x, we get a negative 2y, and then of course we get a 0z. So let's just put that in here in kind of a plus 0z equals 5, and of course that's not going to follow us through. But that equation right there is a two variable equation in x and y. So that elimination is done. Now we want to do a second elimination. The second elimination we don't have quite the freedom that we did with the first elimination. We remember with the first elimination we could choose any two equations and eliminate any variable. With the second elimination, really we are going to need to choose, we have to use the equation we haven't already used. So we're going to have to use row 3. Alright, so we're going to need to use row 3, and we're going to need to eliminate z again. So you have to eliminate the same variable. So let's just take a quick look. That means here's row 3. I've got to use that, and I've got to eliminate z again. So it makes sense for me to probably use row 1 because it's got this negative sign already built in. And of course I have to use row 3, so I'm going to need to take 2 times row 1 and add that to row 3. So let's do that. 2 times row 1 is going to be 2x plus 4y minus 2z equals 10. And then row 3, just as is 3x plus 2y plus 2z equals 3. And so completing that elimination gives us 5x plus 6y equals, well, I guess let's put that in there, plus 0z equals 13. And so that's our second equation, another 2 by 2 equation. So let's write down our new two equations that we're working on. So the first one is going to be 3x minus 2y equals 5, and the second one is 5x plus 6y equals 13. Those two equations that we obtained from the two previous eliminations. Alright, but notice that's a 2 by 2 system, and so we can use elimination now in a much more familiar setting to solve this system. And so we remember, alright, we take a quick little look and we notice, hey, I should be able to eliminate y's pretty easily because I only need to multiply the top equation by 3. So let's write that down. We're going to do it this way. We're going to say 3 times row 1, and we better put a little star there just to remind us that's not the same row 1 as we used before. But 3 times row 1, add that straight to row 2 star. So 3 times row 1 is 9x minus 6y equals 15. And row 2, without any changes, is this right here. And when we add them, we get 14x. The y's disappear, which is what we wanted, equals 28. Or just simply 14x equals 28, and we are ready to solve that immediately for x. And so of course x equals 2, and we want to keep track of that because that's the x part of our solution. And we know what we need to do to finish solving the 2 by 2 system. We're just going to plug that x equals 2 into one of these two equations. Doesn't matter which, but we're trying to now find y. So let's plug it just into the first one. 3 times 2 minus 2y equals 5. And that's going to give me 6 minus 2y equals 5. Subtract 6 from both sides. Minus 2y equals minus 1. And so y equals minus 1/2. There's the y part of our solution. So we know what x has to be, we know what y has to be. All that's left is to figure out what z has to be. And so we're going to take the two values that we have, x equals 2 and y equals negative 1/2, and plug them into one of these. So let's just plug them into the top equation in order to figure out what z needs to be. So it's going to look like this. X is, oops, we know what x is. Let's write down our equation. I'll just write it down so we know what we're doing. X plus 2y minus z equals 5. X is 2. Y is a negative 1/2. Excuse me, yeah, it's a positive 1/2. Oops, we gotta go back here. This should be a positive 1/2. So, hope that didn't cause too much panic for you. I know you were screaming at the screen. Let's treat it like a positive 1/2. Minus z equals 5. So that's 2 plus 1 minus z equals 5. Minus z is going to equal 2 when I move the 2 and the 1, which is 3, over to the other side. So z equals negative 2. And so there's our value for z. So our solution is x, y, z. And that is the solution to the system. Notice, and we could check it by plugging it into each of the equations, first of all, but just look at the process we did. We basically did 3 eliminations, and then that allowed us to start identifying the value of these variables.